This is Integrated 2, 5.1.1. So we are going to be starting a new essential skill, but it really does kind of follow well factoring, which we just finished. So we're going to be utilizing factoring. We're going to keep talking about quadratics. And the main focus really is going to be quadratic functions themselves. We'll be talking about how you graph them, what the equations look like, that type of stuff. So a couple vocabulary things. These are going to come directly from the notes. Whenever you're talking about the graph of a quadratic function, well, the graph of a quadratic function we call a parabola. So it's going to be the graph of a quadratic function. It looks like a bump or a dip when you graph it, at least the ones that we're going to be dealing with. Now, vertex, very important point on a parabola. The vertex is either going to be the absolute lowest point on the parabola or the absolute highest point, depending on how the parabola is oriented. So if the parabola opens up, so it looks like a dip, then the vertex is going to be the lowest point. If the parabola opens down, so it looks like a bump, then the vertex is going to be the highest point. Another way to take a look at it is where the graph changes direction. So if we're going from left to right and it looks like the graph is going down from the beginning, the vertex is where the graph stops going down and starts going up. So we see that little change. Another thing that's important to know about a parabola is that there will always be a line of symmetry. For us, we're only going to be dealing with parabolas this year that either open up or down. So the bump or the dip that I was just talking about. The line of symmetry is going to be a vertical line. It passes through the vertex and it splits the parabola in half. So you've got the left side of the graph and the right side of the graph match exactly. So it looks kind of like a mirror image of each other. All right, so what I have here is I have the equation of a parabola, and then I've got the graph that I went ahead and established. So I want to just kind of point out some of the things that we've got here, and then we'll do more stuff with another equation on the next page. So based off of how this looks, I would say that this is more of a dip. So it looks like kind of dips down. If we take a look, we want to be able to find the lowest point on the graph. On the lowest point, this one looks fairly clear here. It looks like the lowest point within that blue circle is probably that point. So our vertex is going to be that lowest point. Remember that it is a point also. So it's going to be some x comma y. Then our line of symmetry, so that invisible it's not really technically a part of the graph, but it does give us kind of that balancing point for this thing. So if I went through and I want that vertical line to go right through that point, and it should look like it splits the graph in half. So if we go through and we draw that in, I want you to imagine folding the graph over that line. So if we did that, then that means that the left-hand side and the right-hand side would match up perfectly. This is the line of symmetry. Now, the line of symmetry is going to be for us the entire year a vertical line. A vertical line is always x equals, and it's going to be some number. So in this case, it looks like it's at x equals 1. Now, the whole idea of symmetry, and this is actually pretty nice, is as you find points on one side of the line of symmetry, you can find its partner point on the other side. So if I pick a location here, so I'm going to go ahead and put a green box around the area I'm looking at. I'm going to go all the way across the graph there. If you start at the line of symmetry and you count to the left to find a point on the parabola, then you actually have to be able to count the exact same distance from the line of symmetry on the other side. And it will have a partner point at that location. So this distance of 2 to the left is going to be 2 to the right as well. And actually, if you look all the way up, you can pick any other location on the graph as well. It doesn't even have to be like a +2 distance or a +3, or it doesn't have to be a nice distance. You just count the boxes. So there's 1, 2, 3, and notice it's a little bit further. You'd want to go the same distance to the other side. So 1, 2, 3, and a little bit further. Those are the exact same distance away from the line of symmetry. So basically, if you find the vertex and you find points on one side of this parabola, then you can find all the points on the other side too, or at least some partner points on the other side. Okay, so moving on, let's actually go through and come up with some of this stuff ourselves. So this whole idea of investigating, well, to be able to investigate a function, we're looking for a whole bunch of things. I mean, not a gigantic amount of things, but definitely some things. So I think I'm going to go back to the previous slide and let's just make a list here of what it means to investigate a function. So to investigate at this point, now in higher levels of mathematics, they're going to add more stuff to the list. To investigate, I am going to expect you to tell me what the X-intercepts are. Remember, X-intercepts are points, so they're going to be some number, comma, 0. There's probably going to be, or could be 2 of them, so you may have multiples. Y-intercept, well, this is going to be 0, comma, some number. There's only ever going to be one of those. The vertex, which is going to be some xy that we find. Remember, it's going to be in the middle. The line of symmetry. So we kind of have a laundry list of things that we need to do. Our line of symmetry, remember, is always going to be x equals some number. And then we're going to have domain. So you're now going to do a bit of review. And remember that these are the x values. Typically the input is what we would call them. And then the range, which is normally the y, but also generically called the output values. And then last but not least, you need the graph. So those are the things that we're going to be looking for when we're asked to investigate something. So we'll need to know that list, especially on the next slide. Okay, so on this one, to be able to investigate this function, I'm going to show you some techniques later this chapter to be able to come up with the points. But at this point in the chapter, I think we're just going to start by making an XY table. I think that would actually be a really good idea. So we're going to make an XY table here. And then ultimately, how you organize this is up to you. It really is your choice. I'm going to go ahead and orient it, I think vertically, probably make it a little bit more organized for me. And then I'm just going to start adding values, and I'm going to make a pretty big table to start. And then once I feel like I have enough, so I want that idea of symmetry to help myself out. Once I think I have enough, then I should be able to use symmetry to help myself out here. So I think what I'm going to do is I'm going to start with what I think are the usual points. And for me, that's -2, 0, -1, 0, 1, 2. So what I'm going to do is I'm just going to take those, I'm going to start plugging them into my function. So I'll show you one of what I mean. So everywhere I see an x, I'm going to plug in a -2. And then from here, I'm going to go ahead and simplify it and see what I get. Okay, so -2 squared is going to give me 4. -2 times -2 is 4. Bring that -15. I think that's going to give me a -7. Okay, so -2, -7. I don't mind plotting that. That's not huge. Okay, let's now plug in -1. So all I'm going to do is just keep going back to my original function and just plugging the next value in. So that's going to give me a +1, a +2, a -15. Okay, I think that's going to give me a -12. Okay, -12, not thrilled about that. So if I take a look at these points, it looks like my y values are going down. Okay, well, let's see if I can find a bottom point here. So I'm going to keep going. So I'm just going to go ahead and keep plugging these in and see what happens. Okay, that's going to give me 0. Doesn't matter if it's -0 or +0. I think that's going to give me a -15. All right, -15. Why don't you go ahead and plug in 1 and 2 and see what we get. Okay, so here are the values that I've gotten so far. Now, I would be a little concerned if it just looked like the numbers kept going down, 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 but I see that it looks like it turned back around. So what I'm looking for is this idea of symmetry. I want these things to look like, so my y values, I want them to start matching, which they did. So if I look, you can see that I got 2 -15s with that -16 lower dip in the middle. So I think I'm going to keep going here. So let's try 3 now. And I have a prediction of what I think is going to happen because of symmetry, but I'm going to double check and make sure that that's actually right. So it's going to give me 9 minus 6 minus 15. If I do that, that's going to be 3 minus 15, which is -12. That's exactly what I expected because you'll see that I start having this balancing happening. Okay, when I plug in 4, I've got my prediction. Why don't you plug it in and see if you get what you think we should? And it did match, which was my expectation. So I think I have enough points right now to start graphing this, but I'm concerned because I still need to be able to find the X-intercepts. If you look at this, I have the y-intercept. That's totally fine. So let's write that off to the side. I've got part of it. So I've got my y-intercept. I know my y-intercept because it's in the table. Remember that a y-intercept is always going to be 0, some number. So in this case, I do have 0, -15. So I've got my y-intercept. But I don't have my x-intercepts yet. So I think what I need to do is I need to keep picking some points. Hopefully I'll stumble upon 0 in my y column. Then maybe I could do some symmetry. So why don't you plug in 5 and let's see what happens. Okay, good. I found one. Now, if I hadn't, and I was still in the negative numbers, remember my graph is slowly coming up, so I would keep going until I hit 0. Now, understand there are going to be some questions in the future we're going to have to use a different technique for that. But for now, I think just a table will suffice. Okay, so I found one of the x-intercepts, but I think I can find the other one just using symmetry. So going back to my table, knowing that I've got this symmetry thing, this 0 should match up with whatever would be above this one. And I think that's going to be -3. So I think our x-intercepts, we are going to have 2 of them, is going to be -3, 0. Remember to write them as points, and 5, 0. Okay, I have a better idea now of what's going on. So got my y-intercepts highlighted yellow. Let's go ahead and highlight our x-intercepts purple. So it would be right there and there at 5, 0. Now, using this whole idea of symmetry that's been happening, I think we even know the vertex. So let's take a look back at the table. And it is that middle point where the y values started balancing each other out. So I think it's going to be at 1, -16. So let's go ahead and write that down. So we've got our vertex. Of 1, -16. Okay. Domain and range, I think we still need to be able to do. Line of symmetry. Oh, we can do this. Okay, the line of symmetry is going to be the exact same x value as the x value of the vertex. So go back to the vertex. So should we write x equals. Go back to the vertex, grab the x value of the vertex, and we're going to copy that down for the line of symmetry. So we went ahead and grabbed it out of there, and we wrote it as x equals. Okay, we've got the line of symmetry is done. Domain and range, I think, is going to be a little bit easier once we have the graph. So let's go ahead and take a minute and go ahead and plot the points that you have. Then I think we can talk about domain and range. Okay, so here I've got my graph of the equation. It does continue on, so let's go ahead and put some arrows at the end of the graph. You will see that I've got my y-intercept down at 0, -15. So that's my yellow plotted point. You will also see that I have my X-intercepts plotted. So from my table, there's the -3, 0 and the 5, 0. I can also go ahead and add my line of symmetry to this as well. So let's go ahead and put that down the middle. Oh, let's put the vertex on first. So the vertex itself is down at 1, -16. It is the lowest point on the graph. And then if we put our line of symmetry through that, you can also see the balance. So if we take a look back at the X-intercepts, if we count the distance, we know that that's 1, 2, 3, 4 to the left, 1, 2, 3, 4 to the right. So it's balanced like it should be. Okay. The next thing we really need to talk about here is domain and range. Now, there's a beautiful part about quadratic functions that I think you're really going to like, is that domain represents all of the x values that you're basically allowed to plug into the equation. Well, if you have a quadratic equation like the ones you and I are going to be dealing with, the domain is everything. You can plug in any number you want. So there's a whole bunch of different ways to answer this. You can say the smallest possible number you can imagine, which is -infinity, or at least the notion of the smallest number, to the biggest possible number you can imagine, which is to positive infinity. But this can also be written another way. This can be written in inequality notation. So now we take what we've got here, the smallest number on the left-hand side, leave some space, biggest number, or at least idea of the biggest number on the right-hand side. Remember that domain represents x values, put the x in the middle. And then we're going to say that x is bigger than the smallest number, so the open math on the inequality eats the x, but it is smaller than the biggest number, infinity. So that's another way to write it. Or, now you don't have to do all of these, you need to choose. Or we're going to go ahead and take the smallest number on the left, comma, biggest number on the right, and then we're going to use parentheses on this. Now, I know it looks like a point or an ordered pair, but it's not. This is called interval notation. So we would say the smallest we can get is close to, so parentheses, close to -infinity. And then the biggest number we can get to is close to positive infinity. We can't really get there. So the parentheses represent close to, as close as you can possibly imagine. But this can also be written another way. When you're talking about -infinity to positive infinity, that represents all real numbers. So we can say all real numbers. However, in math, we have shorthand for almost everything. All real numbers looks like a capital R, but it's got an extra bar next to it. So 2 bars and then an R. So all 4 of those answers are totally acceptable for domain on this question. Now, range, and then remember, domain is x's. Range can also be written a couple of different ways. So if we do the range, that's going to be your y's. We always want to go from small to big. So we're going to go from bottom to top. So if you take a look, this clearly has a bottom location that it goes to. So the lowest this thing possibly would go is right where the vertex is located. So we're going to just put that black line. That x value, that y value is at -16. So the lowest this thing could go would be -16. But then as you scan your way up, there's going to be these arrows pointing up. That's going to be the highest possible number, or biggest possible number we can imagine. It's going to be positive infinity. Okay, but then this can be written all those different ways. So put the small number on the left-hand side, put the big number on the right-hand side. This is y because it is range. You're always going to be less than infinity. Can't really get to infinity. The -16 is a little bit trickier though. So we're going to be bigger than it, but there's an actual point there. So you could actually be equal to. So that's another way to write it. Or we can do small number, comma, big number. Now, not only are we going to be able to get close to -16, but we actually hit it. If we hit it, we're going to use brackets. Infinity, though, you can't really get there. The best you can do is just get super close so you can get infinity. You can't say all real numbers. All real numbers only applies to negative infinity to positive infinity. So let's see. We have everything satisfied. X-intercepts, check. Y-intercept, check. Vertex, check. Line of symmetry, check. Graph, yes. Domain, range, absolutely. So there's our investigating of a quadratic function.